Hello! Today we will be learning about Unit 4, the structure of substances. The main contents of Unit 4 are historical development of the atomic nature of substances, atomic theory, the structure of the atom, and molecules. After completing this unit, you will be able to narrate the historical development of the atomic nature of substances, state Dalton's atomic theory and modern atomic theory, describe the structure of an atom, explain the terms like atomic number, atomic mass, and isotope, appreciate the importance of study of subatomic particles and understanding properties of substances. Explain the arrangement of electrons in the main energy levels and write the electronic configuration of the first 18 elements. Differentiate molecules of elements from molecules of compounds. But first, a historical note. John Dalton began his study in meteorology, the study of gases, of the air, and their ultimate components. In other words, weather. Subunit 1. Historical development of the atomic nature of substances. By the end of this subunit, you will be able to narrate the historical development of the atomic nature of substances, and compare and contrast the continuity and discreteness or discontinuity theory of matter. In the continuous theory of matter, Plato and Aristotle believed that matter is continuous. That means that matter is infinitely divisible. That means if you take something like a piece of paper, you can continue to cut it forever and ever, and there will never be a limit. Democritus gave the discrete theory of matter. He believed that matter is discrete, or not continuous. If you start to cut a piece of paper into smaller pieces, there is a point where you must stop cutting. Democritus proposed that all matter consists of very small, indivisible particles that we now call atoms, from the Greek word atomos. That means uncuttable or indivisible. In summary, the idea that matter consists of discrete, indivisible parts called atoms was introduced by Democritus. Discrete theory of matter states that there is a limit to which matter is broken or divided into pieces. Continuous theory of matter states that matter is infinitely divisible. In review, what do you mean when you say a substance is continuous? A substance is continuous means it can be divided endlessly into smaller pieces. What do you mean when you say a substance is discrete? A substance is discrete means there is a limit to which matter is broken or divided into pieces. Subunit 2. Atomic theory. By the end of this section, you will be able to state Dalton's atomic theory, describe the shortcomings of Dalton's atomic theory, and state modern atomic theory. What are the main points of Dalton's atomic theory? The main points of modern atomic theory are An element is made up of small particles called atoms. Atoms are divisible. They can be broken up into protons, electrons, and neutrons. All atoms of the same element may not have the same mass. Atoms of different elements are different. Atoms of different elements combine in small whole number ratios to form compounds. In ordinary chemical reactions, atoms are not created, destroyed, or changed, but they are joined, separated, or rearranged. In summary, modern chemistry began with Dalton's atomic theory, which states that all matter is composed of tiny, indivisible particles called atoms. According to the modern atomic theory, an atom consists of a very dense central nucleus containing protons and neutrons, with electrons moving around in the nucleus at a relatively large distance from it. List the main ideas included in Dalton's atomic theory. The main ideas of Dalton's atomic theory are: matter is composed of a large number of atoms, which are small particles that cannot be created or destroyed or divided. All atoms of an element are identical in every way. Chemical combination takes place between small whole number of atoms of the elements concerned. What are the shortcomings of Dalton's atomic theory? The shortcomings of Dalton's atomic theory are: atoms are indivisible. We know that atoms are divisible into protons, neutrons, and electrons. Atoms of the same element are identical. This is not the case. We will learn about this in the upcoming units. According to the modern atomic theory, atoms can be broken down into what three substances? Electrons, protons, and neutrons. Subunit 3. The structure of the atom. By the end of this section, you will be able to describe the atomic nucleus and electronic shell as the two parts of an atom. Define atomic number and mass number. Calculate number of protons, electrons, and neutrons from atomic number and mass number. Define isotopes. Define atomic mass. Define energy levels. Represent energy levels by letters and numbers. Describe the maximum number of electrons each energy level can accommodate. Define electronic configuration. Write the electronic configuration of the first 18 elements in the main energy levels. Define valence electrons. Determine the number of valence electrons of the first 18 elements. Define ion, and give examples of positive and negative ions. An atom contains protons, which are positively charged, electrons, which are negatively charged, and neutrons, which have no charge, hence they are neutral. Protons have a relative charge of +1. Electrons have a relative charge of -1. Protons and neutrons are located in the nucleus of an atom. electrons surround the nucleus of the atom. Let's see a video about an atom and its parts. What is an atomic number? It is the number of protons in the atom. The atomic number equals the number of protons in an atom. Or Z, which stands for atomic number, equals P, or protons. What is a mass number? It is the sum of the number of protons and neutrons in an atom. So A, or mass number, is equal to P, or protons, plus N, or neutrons. The mass of electrons are negligible, so that's why they are not in this formula. The chemical notation of atomic number and mass number are A, or mass number, is on the top left of the symbol of the element. Z, or atomic number, is on the bottom left of the symbol of the element. For example, what is the atomic number, mass number, number of protons, number of electrons, and number of neutrons for the element 23 sodium? First, the number of protons are 11. That's because Z, or the bottom left of the sodium, is 11. The mass, or A, is 23. We know that A equals P plus N. So if we rearrange that formula, we get 23 minus 11 equals 12. 12 neutrons. Because this atom is chargeless, we know that the number of protons equals the number of electrons. So there are 11 electrons. What are isotopes? They are atoms of the same element that have the same number of protons but different number of neutrons. For example, hydrogen has 3 isotopes. There is protium, which only has 1 proton. Deuterium has 1 proton and 1 neutron. Tritium has 1 proton and 2 neutrons. When we talk about atomic mass, we often talk about the average mass of all the elements isotopes in the universe. So the atomic mass is equal to the product of the mass of the first isotope multiplied by the abundance of that isotope in the universe. Then we add this to the mass of the next isotope times the abundance of that isotope in the universe. So for boron, which has 2 stable isotopes in different percentages, 20% of the atoms are boron 10, and 80% of the atoms are boron 11. What is the average atomic mass of boron? First, we take the product of the mass times the abundance of the first isotope. Then, we take the mass times the abundance of the second isotope. So 10 times 20% plus 11 times 80%. That is 2 plus 8.8 is equal to 10.8. So the atomic mass of boron is 10.8. What are the energy levels? I've already told you that electrons revolve around the nucleus. They do so in shells. The shells are the regions where the electrons surround the nucleus of an atom. This is a very oversimplified depiction of those shells. Only certain orbits are permitted for electrons to revolve around the nucleus. As electrons occupy further away from the nucleus, their energy increases. Any electron that is farther away from the nucleus has greater energy than those that are closer to the nucleus. That's why these shells are called energy levels. What is electronic configuration? It is the arrangement of electrons in the shells of atoms. There's a maximum number of electrons that can be in each shell. For chlorine, there are 2 electrons in the first shell. There are 8 electrons in the second shell. There are 7 protons in the last shell, but that is because there are only 17 protons in chlorine. So the last shell is not all the way filled. Example 2, carbon. There are 6 protons in carbon, so there are 6 electrons in carbon. The first shell can only contain 2 electrons. Then there are only 4 left. They go in the second shell. Example 3, fluorine. There are 9 proteins in fluorine. 2 electrons are in the first shell, then the remaining 7 are in the second shell. What are valence electrons? Valence electrons are the electrons that are found in the outermost shell of an atom. If you remember from Unit 3, we called these valence numbers. They were the combining power of an element or polyatomic ion. That's because the valence electrons are those that are involved in forming chemical compounds. A valence shell is the outermost shell of an atom. In summary, protons are positively charged, neutrons have no charge, and electrons are negatively charged. A proton and a neutron have approximately the same mass, but the mass of an electron is negligible. The atomic number of an element is the number of protons in the nucleus of an atom of the element. In an atom, the number of electrons equals the atomic number. Hence, an atom is electrically neutral. The mass number is the sum of the number of protons and the number of neutrons in the nucleus of an atom. Isotopes are atoms of the same element with the same number of protons but different numbers of neutrons. Electrons occupy certain energy levels outside the nucleus of an atom. These energy levels are also known as atomic shells. Electronic configuration is the arrangement of electrons in atomic energy levels. Valence electrons are the electrons in the outer shell of an atom. The outer shell of an atom is also known as valence shell. An ion is an atom or groups of atoms that is positively or negatively charged. What are the atomic numbers and mass numbers of an element that contains 4 protons, 5 neutrons, and 4 electrons? Z equals P, so the atomic number is 4. A equals P plus N, So the atomic number is 4 plus 5 equals 9. What is the charge of a proton? Plus 1, minus 1, 0, or plus 2? Plus 1. Which of the following is the correct electron configuration for an element containing 17 electrons? 2, 8, and 7. 2, 8, 18, and 7. 2, 7, and 8. 2, 18, 8, and 7. 2, 8, and 7. What is the maximum number of electrons that can be accommodated in the L shell? 2, 8, 18, 32. Answer 8. Which of the following subatomic particles are found in the nucleus of an atom? A. Electrons and protons. B. Protons and neutrons. C. Electrons and neutrons. D. Electrons and positrons. Protons and neutrons. Subunit 4, Molecules. By the end of this section, you will be able to define molecules, give examples of monoatomic, diatomic, and polyatomic molecules, and differentiate molecules of elements from molecules of compounds. What is a molecule? It is the smallest particle of an element or compound. It can be classified as molecules of elements, molecules of compounds. For example, on the top, there are molecules of elements, and on the bottom, there are molecules of compounds. Molecules of elements are classified into monoatomic, diatomic, and polyatomic. For example, neon, argon, helium are all monoatomic molecules. The noble gases are able to make monoatomic molecules. Nitrogen, iodine, oxygen, and hydrogen are diatomic molecules. Ozone, phosphorus, and sulfur are polyatomic molecules. That is because they are made up of more than 2 copies of the same element. Molecules of compounds are formed when atoms of different elements are combined together chemically. For example, water or H2O, carbon dioxide, carbon monoxide, and sulfur dioxide. These are all molecules of compounds. In summary, a molecule is the smallest particle of an element or compound that can exist freely in nature. Molecules of elements consist only one type of atoms and exist as monoatomic, diatomic, or polyatomic. Molecules of compounds consist of 2 or more different types of atoms. Which of the following is a polyatomic molecule? Phosphorus, water, bromine, or carbon dioxide? Phosphorus. Which of the following is a molecule of a compound? Bromine, ozone, sulfur, or carbon dioxide? carbon dioxide.